Glide reflections, it's a two-step transformation. The glide is a slide or a translation, and then you reflect it. So you're doing two things to it. So you slide it over and then you flip it. That's all a glide reflection is. Composition is doing two or more things. Okay, so a glide reflection has its own name, but you can do a reflection and then a rotation, or a rotation, then a reflection, or whatever. Okay, so composition is just telling you to do, we're probably just going to do two things. So here's an example of that. Sketch the image of ABC after the glide reflection. So here's the two things we're doing. First you do that, then you do that. So here's the triangle. So we got to translate it. Everyone remember how to read those? So you don't do anything side to side and you move it up 8. So there would be A prime, B prime, and C prime. So there's the glide, the translation. Now we got to reflect it in the y-axis. Here's the y-axis, so it's going to flip over here. So remember, the points just stay the same distance away. A prime is 2 away, so you go 2 on the other side. It's A double prime. B is at 7, so B double prime would flip over here to -7. And then C would flip over here. Okay? So it's just 2 and 1. Do you think it would matter if you did this backwards? Would you end up in the same spot if you did this first and then that first? You think so?
No.
No, because if you flipped it, it would go here. Like this. And then if you slid it up 7, well, maybe this is A prime, B prime, C prime. 1, 2, 3, 4, 5, 6, 7.
8. 8.
Oh, it's 8. Yep. So it would end up in the same spot.
Yep.
Okay. Okay. Now, when we do the test, which we're getting close to the end of the chapter, on the test, most of it is just a point. So you're going to have a graph. They tell you the point, which is 4, -2. So remember, it's positive 4, so you go right 4 and then down 2. So when you do this, you can just label it P. Then you got to do the two things it tells you. Translate it, x plus 4, y is nothing. So that means I got to go right 4. So P prime would be right here. And then, so I took care of that. Then reflected in the x-axis. So it's 2 away from the x, so you'd go 2 up here. There's P double prime. Okay? The problems on the test are exactly like this one. Seems like every year people struggle with this for some reason. I've never been able to figure out why. So, it's nothing harder than that. You plot the point. P is 4 over 2 down. Label it. Translate it. X means nothing side to side. Y -6 is down 6. So that'd be right there. Oops, just P prime. Then reflected in the y-axis, it would flip over to here. P double prime. Okay? Easy enough?
Yes, sir.
I think so too. Okay, so this is the same thing. The composition of 2 or more isometries is an isometry. That just means When you do two or more things, it's gonna stay the same. So these are the same thing as what we did up here, except it's not a glide reflection. You're just doing two other things. Here, first you're gonna rotate it, and then you're gonna reflect it. So it's just a line segment. So to rotate this 90 clockwise about the origin, remember this is the hardest one. The 90 clockwise, these two are gonna end up here because it's a fourth of a turn. And what you do is you count how to get there and then you do the opposite. It's down 2 over 4. So the opposite of over 4 is up 4. And the opposite of down 2 is over 2. So there's the new M. And you could check it by drawing that. It would form a 90. And they'd be the same distance away from the origin. So N is down 5 over 2. So the opposite of down 5 is over 5. The opposite of over 2 would be up 2. Okay, you guys remember the rotations? All right. So there we took care of that. Now we got to reflect it in the x-axis. Here's the x, so it's going to flip down here. N is 2 away, so it would go to there. There's N double prime. That's 4 away, so it would go down here. So that's what it would look like. A rotation and a reflection. Describing them. Here's the original. Everyone knows how to tell which one it goes to first? Prime, right here. So, obviously to get from here to here, it's not a translation because it's upside down. It looks like a rotation to me. I mean, yeah, rotation. It's not a reflection because it wouldn't fold. So, it should be 180 degrees. And in order to check that, is if you connect all the points, they do form straight lines, right? Through the origin. So the first thing it's done is it's a 180 degree rotation through the origin. Then, what does it do to get from here to there? Then it's a translation, so you'd put translate. You could write it as a vector component form if you wanted to. It's shorter, or the book would do it this way. Pick any point, Q, P, or R, and figure out how you get to the other point. So like from R to R, I gotta go over 6, so you put X plus 6. And then I just gotta go up 1, so it'd be Y plus 1. Okay? The rotations are the hardest one to describe. Translations are easy. Reflections are easy. So, like this one, here's the original. There's the first image. What do they do? Translate. So to get from A to A prime, it goes right 1, 2, 3, 4, 5, 6, 7. So you put X plus 7 and then just a Y because it doesn't move up or down. Then to get from here to here, 180 rotation through the origin. Okay, this one is a reflection. So here's the original. It moved to there. So there you can see that is a reflection. So you'd say reflect in. So what is the line that it reflects over? The x-axis right here. And then it reflects again, because you can see the B's are here, the A's and the C's, so it reflects right there. It doesn't slide over, because if it slid over, the B would still be on the left. So the second thing it does is it reflects in, what's this line called, right? X equals 6. Crosses the x-axis at 6. Okay?